Welcome, everybody. Hi, I'm Dave. We'll get started as usual at the top of the hour. Come on in, find a seat, grab your snacks. This is great. Had a lot of interest today. Fantastic. All right, it is the top of the hour. Hello and welcome, everybody. My name is Alan Barr with COEH Northern California. And on behalf of the NIOSH-supported education and research centers throughout the country, we're pleased to present the 2023 ERC Ergonomics webinar series, where we offer free monthly webinars on various topics on human factors and ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you so much for joining us today. All participants who logged in today with their registration email will receive a link to an evaluation form that will qualify you for a certificate of completion worth 1 continuing education contact hour. Please consider joining us on September 20th for our next Ergo webinar, which is Workplace Design Considerations for the Aging Workforce and for All. You can register for that and other upcoming webinars, of which there are many, at coeh.berkeley.edu/webinars. You will be muted during today's webinar. If you'd like to ask a question, and I encourage you to do so, please enter it into the online Q&A. We'll save some time at the end of the presentation to address those questions. Today's webinar is being recorded and will be made available along with past webinars on the COEH Northern California YouTube channel. Please take a moment to like and subscribe to our channel so we can continue to grow. Today's webinar, the title of which is How World-Class Ergonomics Programs Are Using Technology. Our speaker today is Julia Abate. Julia is the Executive Director for the Ergonomics Center, housed in the Edward P. Fitz Department of Industrial and Systems Engineering at North Carolina State University. She is a certified professional ergonomist with over 25 years of experience helping companies develop and grow their ergonomics programs. She has degrees from the University of Michigan in Mechanical, Industrial, and Operations Engineering. Julia is currently a program chair for the Applied Ergonomics Conference and one of the technical vice presidents for the Institute of Industrial and Systems Engineering. She also serves on the advisory boards for the IISC Transactions on Occupational Ergonomics and Human Factors, the North Carolina Occupational Safety and Health Education and Research Center, and National Safety Council's MSD Solutions Lab. Pretty awesome. With that introduction, Julia, I'll hand it over to you.
Thank you, Alan, and good afternoon. Before we start, I'd like to thank the North Carolina Occupational Safety and Health Education and Resource Center and the other centers listed here for allowing me to speak today. And thank you for joining us as we take a look at how some of the companies with world-class ergonomics programs are using technology to more effectively identify and address ergonomic risk in their processes. And I was scanning through the participants. I think some of you may see some of your companies and some examples highlighted in here. So thank you for those. And one quick disclaimer, I've tried to use industry examples throughout the presentation and have referenced the sources accordingly. Any vendor pictures that are used are for example only and don't imply an endorsement of the product. The links that I've provided, you should be able to access and find in the future. And some of them you can just do a quick Google search on, and I'll tell you where we do those. So thank you again, and we'll get started. So first of all, let's talk about what it means to be a world-class by looking at a spectrum of programs, starting with programs that are in this firefighting mode. In firefighting mode, injuries are going to be expected. Some employees have nominal awareness of the basic ergonomic principles and tools. Issues are typically identified and addressed after they've caused injuries. And firefighting programs are typically expert-driven and may have slightly oppositional relationships with productivity. As we go up the spectrum, a reacting program is going to be one where ergonomic risk is addressed reactively and inconsistently. So injuries are often blamed on the employees. Back in the day, it used to be, oh, the employee didn't use the right work methods, instead of something that might be more of an engineering or a physical fix. Ergonomic efforts might also be led by EHS on short-term campaigns. So it's a part of that overall program, but it's not on its own. A complying program will take a more formal, compliance-driven approach to ergonomics. They might form an ergonomics team that tackles easy solutions and measures their results. Execution at this point becomes more consistent and standardized. And then in the preventing stage, when a program has reached that stage, employees are typically understanding the ergonomic principles. They're actively applying the tools and what they learn. The implementation of program elements is executed more consistently, and management is committed to being more proactive, often integrating ergonomics into their design guidelines. At the world-class stage, ergonomics is embedded into the company culture. There's usually an implied zero injury goal, and leading indicators are tracked to manage risk, which is also consistently addressed. These programs are typically participatory in nature, and they empower employers to make changes and share best practices. Typically, these world-class programs tend to have a strong proactive policies that avoid introducing new risk of injury into their new systems. They capitalize on the fact that when a product or process is in the early stages of design, there's funding available and allocated to the development and testing of that product or process. The cost to make changes is also much lower when in the design process, prior to that physical build. As the project moves closer to completion, fewer funds are available for changes. And once the product or process is built in a manufacturing environment, it's not only more costly to implement change, but the funding is usually much harder to come by. For the purposes of this webinar, we're going to break down the technology applications into two categories to reflect the changes made proactively, so before that build point, and those made reactively after a product or process has been released or in manufacturing. So how do these world-class companies use technology to address potential issues prior to that build point? Most of them are utilizing digital human modeling, virtual reality, or augmented reality, or a combination of all three, to test out their designs on their new products and processes virtually. And then they also use augmented reality and virtual reality to provide training on those products and processes when it does go into that manufacturing phase. So just to make sure everyone is on the same page, that virtual reality or VR immerses a user into an alternative digital world or reality, separate from the real world. So we're thinking Matrix or Avatar. Augmented reality or AR is technology that overlays digital information into the real world or on real world elements. Examples include heads-up displays or the tracking that's overlaid in Olympic athletes to kind of show viewers at home how that athlete is performing when compared to a world record. Digital human modeling is used to incorporate ergonomics into early product and process design, with or without that augmented and virtual reality. Now, using digital human modeling helps engineers identify and address the issues involving fit and clearance and reach prior to any equipment being built. And this process can save companies millions of dollars in development costs. The digital human also allows companies to test out that smaller 5th percentile female and the larger 95th percentile male model to see how they interact with the process. And they can test models from different geographical regions where they might have plants in Mexico or Asia, and those employees are going to have different statures, different sizes. So this example comes from Ford's virtual reality lab. The immersive VR, as Ford calls it, allows rapid prototyping throughout design and engineering development. And it also allows engineers to collaborate remotely. Ford has been using digital human modeling for over 20 years, and in this example has incorporated a 3D printed model of a product design. In addition to having engineers use VR, Ford has also been known to bring line operators into the virtual labs to evaluate the future model assemblies and to identify potential problems the engineers might miss. In 2017, Ford reported that since the beginning of its virtual manufacturing program, they'd reduced overextended movements, difficult hand clearances, and hard to install parts in new vehicle launches by 90%. They also reported reducing employee injuries and by 70% and employee days away from work due to injury by 75%. Lockheed Martin has also developed their Collaborative Human Immersive Laboratory, or CHILL for short. It's a virtual 3D simulation lab that allows virtual creation of a spacecraft before the physical creation. Engineers and technicians can view those 3D models in AR space or step into their creation as avatars to enhance design concepts and spot and resolve problems before that build phase. This means improved performance, less cost, shorter implementation time, and lower risk. They also report that the ability to visualize engineering designs in virtual reality offers them a tremendous savings in time and money compared to using physical prototypes. And you can search on the Lockheed Martin CHILL Lab through Google and see some short videos on what they're doing. Lockheed Martin is also using augmented reality to develop instructional manuals that include animations for the assembly of spacecraft components. They report significant decreases in the amount of time it took to employees for them to interpret those instructions. And they reported reduced training time by 85% and increased productivity by over 40%. And then John Deere is another company that's been using virtual reality to optimize the design of their tractors by displaying the steps in the build processes. And the engineers were checking for tooling and other clearances and key design features in that virtual environment before that product goes to production. This allows them to tweak the design and make sure employees and manufacturing are accommodated and can build the product without running into any problems. So why isn't everybody using AR and VR and digital human modeling? Well, there are many challenges involved with implementation. Cost is always the number one factor to consider in anything, especially with emerging technology and business. There's also significant investment needed in the technology hardware, the software, and the talent. Lockheed Martin estimated that their initial cost to set up their CHILL lab in 2010 was $5 million. Now, once you get the lab set up, it also takes skilled and trained employees to run it and maintain it. And there are costs associated with finding, training, and keeping those resources. From a data accuracy standpoint, these systems are some of the most accurate systems available. However, some of the graphics are not all equal, and they leave the users a little skeptical. The hand models and the hand interface, for example, if the hand is grasping a tool, they usually have a little bit of a challenge because that might overlap with the tool. So some of the users don't feel it's accurately depicting what they're doing. Process integration, in order for AR and VR or digital human modeling to work, they need to be integrated into that design process where it becomes not an optional tool, but a required validation step in the process. And doing this takes time and it takes a dedicated effort from management. And lastly, data storage and processing. The data that's generated is huge, and the processing power that's needed to analyze this data can take some major computing effort, and it's not inexpensive. Finding ways to amass all the data, make sense of it, provide it for the end users at a reasonable price is still an ongoing challenge. With all of these changes, why aren't people using it? Well, using AR, VR, and digital human modeling reduces the need for that physical prototype, and it can keep those development costs down in the long run. They're also able, the engineers are able to use those designs to design for manufacturability and maintainability. So designing for that upfront and reducing the potential costs for and the future costs of any retrofits. I was talking to my nephew this weekend who is maintaining Humvees, and some of the designs of the structures there just to change the oil are very challenging for them to do. They have to remove several bolts, some of that armored plating just to change the oil. So there are considerations in our designs that we can make upfront in that virtual environment for that maintainability and manufacturability that will affect things in the long run of the product. And those virtual designs also allow engineers to try out different scenarios and layouts and determine which one is going to work best from a productivity and a quality standpoint. Overall, the companies that are adopting these technologies are realizing a positive return on investment, not just with injury prevention, but in time savings, productivity improvements, quality improvements, and employee retention. Going back to Lockheed Martin's Chill Lab, while it cost $5 million to set up in 2010, they estimate that they're saving $10 million a year by implementing the technology in the production line of just their space assets. So the company's already seen a significant return on its investment and will continue to do so. What about companies that can't make that large investment up front? How can they use technology, albeit in a more reactive way? Well, the first place most companies typically start is with training. We've mentioned using augmented and virtual reality for training, but one other way is to use short video segments to train workers on a specific task or content like ergonomic risk factors. Why is this something to consider? Technology is making it easier for anyone to create these types of tutorials. And if you think about it, what's the first thing you do when you need to do a task you've never done before? Excuse me. Let's say you need to change the handle on a toilet. What's the first thing you do? Pop that in the chat for me. Alan, can we see the chats? I know. There we go.
I can, it should be showing. I just dropped an answer in there for you because, hey,
You did, and that's exactly what I was looking for.
I completely understand that.
Yep. So the first thing we do, we don't reach for the instruction books anymore. We Google it and we look at it on YouTube and find some videos on how to do it. And, guess what? The younger generations have grown up with that model. According to Gallup's research, millennials are expected to represent 75% of the US workforce by 2025. They respond best to visual forms of learning. They expect short, concise, quality videos. They get them on YouTube. That's what they expect in the workplace. So one great example of this approach comes from Dr. Devana Pilchik, who's currently the ergonomics program manager at Cintas. She led a project with her previous team at Gulfstream, where they produced several short, engaging, creative videos on ergonomic concepts for employees, including one that I'm going to highlight here and play for you, where the concept being taught is that the primary work zone is from shoulder to mid-thigh and makes a capital I. They made these 2 to 3 minute videos for their employees and posted them on YouTube so anyone can access them by searching Gulfstream Ergonomics. I encourage you to take a look at them and either use them or be inspired to create some of your own. And I'll pop this over here and play it for you real quick.
Hi, I'm Dr. Devana Pilchik with Gulfstream Aerospace, and I'm here today to teach you a lesson in ergonomics on how to identify awkward posture. All you need is a roll of masking tape and a volunteer. And today, we're going to be using our intern, Rachel Ortega. Tear off 3 strips of tape about shoulder width and length. Tape across the shoulders, down the center of the body, and across the middle of the thigh. When you're done, it should look like a capital letter I. Shoulder to mid-thigh makes a capital letter I. This is known as your power zone. The power zone is the area of the body where you are strongest and least likely to be injured. Now, here's how you identify an awkward posture. If the person has to work above the shoulder line with the hands, elbows, or arms, that's not good. These positions place a lot of stress on the rotator cuff. If the person has to work below mid-thigh, like moving boxes or picking things off the floor, that places a lot of stress on the back. And finally, you want to keep work close to the center of the body because it reduces stress on the shoulders and the back. The further the work, the more stress on the body. So remember, shoulder to mid-thigh makes a capital I. That's your power zone, and that's where you want to work.
So that's just a quick example of some of short little videos that engages employees on a concept and teaches them something. I know there's several other companies out there that have done this for their workforces as well. And with the millennials, it's becoming important. They want short, concise training. And we see a lot of turnover with millennials. If they're not happy with a job, they are not afraid to move on. And that's going to play into a little bit when we have a discussion at the end here, but they look for that short, concise training. So the traditional approaches that we've had don't always work. The AR, VR, short videos, those are more engaging for them, and they retain that a lot better. Now, when it comes to evaluating the ergonomic risks of existing jobs, there can be many challenges in today's workforce. Unless you're working in a more traditional assembly line, overall, that job and task complexity have increased, and many jobs are requiring work in awkward postures, confined or restricted work areas, or with greater degrees of mobility. These are areas where traditional ergonomic solutions might not be as practical in challenging industries like construction, service and utilities, maintenance, aerospace, and shipbuilding. You get the idea there. So traditionally, when ergonomists go into do an evaluation, they collect data using the tools you see here. They're manually writing down job tasks, videotaping the work, taking measurements with tape measures, force gauges, and there are strengths and there are limitations to this observation-based approach, especially in some of these challenging locations. You typically need a skilled practitioner or some other trained resource who's developed the skill set to recognize, evaluate, and control the ergonomic risks in the workplace. There can also be concerns around the subjectivity and the accuracy of the data when the measurements are not conducted by a skilled professional. And lastly, the traditional methods take time and they can cause some interruption to workers, even though getting their input is extremely important. So the question is there a better way? And a lot of companies have started using several different options, but one of them being wearable sensor technology combined with machine learning and data analytics to understand the kinematics of employees on the job. These wearable devices can track the postures and movements of employees while they're wearing the sensors. And with COVID-19, they also integrated proximity and location sensors into their technology so they can measure and track social distancing for contact tracing purposes. Some of these devices also provide haptic feedback. So an employee bends or twists to a certain degree, or with COVID, when they were 6 feet apart, it'll provide them some type of haptic feedback and they can adjust their behavior. As far as ergonomics goes, wearable devices are being used to track time spent sitting, standing, walking, climbing, driving, even tripping, while also noting all the high-risk postures like bending or twisting of the back. And again, providing that haptic feedback so that the user can correct their behavior. Some of these devices go a step further and detect environmental factors like temperature, humidity, air quality, barometric pressure, and noise. To our knowledge, many of the vendors of these products have conducted and posted internal case studies with their clients. However, although there are some studies underway, we've yet to see that published longitudinal study conducted by a third party like a university that shows the long-term injury reduction and other metrics after introducing the wearable technology. This is one example of one of those companies that's provided a case study or done a case study on wearables. In 2020, Marisol Barrero, who is currently the Global Ergonomics Manager at Amazon Web Services, she was previously with Toyota, and she reported that Toyota conducted a study at their Indiana production plant where they had 120 employees using wearable sensors over a 2-month span. They reported that the wearables provided a safety score that was essentially automated, which reduced their time to complete assessments on those jobs by 95% when compared to the manual approaches. They also reported that 83% of the employees who used the wearable devices improved their lifting techniques, showing that overall reduction of 50% using their proprietary risk assessment tool. So they saw some benefits to using those wearables. Some companies are also moving forward with computer vision technology to help automate or semi-automate ergonomic risk assessments. And there are several different companies that produce this AI, computer vision, and data analytics for ergonomics analysis. A lot of them, basically, you take a video from your smartphone, load it to a cloud. The software processes the video, automates some type of risk assessment with inputs and outputs, and then try to help streamline that assessment process. And there are pros and cons to this solution as well. This tool allows for assessment of jobs in a quicker time frame than traditional methods, and it's less intrusive to workers. There are also some better visuals depicting those risks that are present on a job, and the videos and assessments can typically be done by novice employees. I do want to throw out some caution, though. We actually conducted a pilot study funded by a grant through the North Carolina Occupational Safety and Health Education and Resource Center. And the pilot study tested the accuracy of several of the commercially available products. And we found that they were not as accurate as some of the vendors say, especially when the joints questions are obscured. This graph shows some of the results with the discrepancies we found in the NIOSH lifting equation, which was used to evaluate a simple lift. If you're interested, Jeff Hoyle, who ran the study, provided an overview of the results in another recorded webinar, which can be found in the link here, which I'll provide to those who request with the PowerPoints. And this is just another example of when you can't see the joint in question, then the computer vision basically can't analyze it. So the results are not always complete in that specific way. And another thing to consider is that it's the same with manual. If the video analysis will only evaluate the employee that it's recorded performing the task, without consideration for employees of smaller or larger dimensions who might have different body angles when doing that same task. When all is said and done, though, these challenges haven't stopped companies from using computer vision technology to identify risk quickly, even though some agronomists will question the validity of the results. And there is work being done to make this technology more accurate in the long run. Another way companies are addressing the data gained through those video-based computer vision systems is to incorporate them with wearable technology. So bringing the two together. The data collected with the wearable sensors and computer vision can also then be integrated with other biomechanics and ergonomic software packages, like the digital human modeling tools we talked about. And there are studies on the validity of this combined technology, both in the lab and in field settings. Next, we have cobots, or computer-controlled robotic devices designed to assist a person. These are typically utilized as an engineering control in industry. And working with and not in lieu of the worker, cobots can complete those tasks that are repetitive or require more physical effort than is safe for the worker to do. And this is one example of how L'Oreal is using cobots to do the heavy lifting at a facility in India. The cobots were implemented to reduce the risk of injury to the workers. However, they reported that using the cobots also increased efficiency at the plant, where the cobots could take and load 2 pallets at a time, and they had to reduce changeover time. Another technology that has seen a lot of growth in ergonomics is the exoskeleton, which is defined as a wearable device that augments, enables, assists, or enhances motion, posture, or physical activity through mechanical interaction with the body. And the one you see is a little clunky because it's a generic Adobe stock photo. Some of them are very streamlined, some of them are very robust, depending on whether it's an active or a passive exoskeleton and which joint or joints it's helping with. So they can target anything from the legs, the back, the shoulders, full body, the fingers. This industry is just growing very quickly. Most of the early adopters of this technology in manufacturing are treating exoskeletons as a form of PPE and instituting them for specific job tasks where no other viable engineering controls have been deemed feasible. Toyota is one company that's adopted to incorporate some of these exoskeletons. And as you can see, the technology journey is a very long-term commitment. And if you guys, I encourage you, Marisol has a recording out there talking about their journey. The path towards that successful implementation of exoskeletons can take years. And companies have to not only identify the job tasks that would benefit from using it, but they also have to determine which type of exoskeleton to use. Every job is going to be different, and the technology that works for one might not meet the constraints of the other. Dr. Christopher Reed has shared that it took Boeing several years to design a process to test and implement exoskeletons in their facilities. If you're thinking about using exoskeletons, there are some considerations you might want to make. First of all, is an exoskeleton the best option? Or can it take the task in question, or can the task in question be addressed with an engineering control? How much will it cost per person? Can the exoskeleton be sized for everyone using it? How much time will it take to train the employees to use the exoskeletons? And will it be optional or mandatory? Will the employees buy into the use of the exoskeleton? How much time will it take to take it on and off? How will you maintain it? And if something breaks, what's the process for fixing it? And what happens in the meantime to that job? Who's going to clean the exoskeleton? And where will it be stored when it's not in use? Boeing has developed an in-depth process for the use of exoskeletons that encompasses all of these questions and more, and it's taken them years to fine-tune and implement throughout their sites. And Dr. Reed is also involved in the ASTM effort to create standards around the use of exoskeleton technology to make sure they're safe, effective, and designed with the user in mind. So the standardization of exoskeleton testing allows companies to compare results across products and with other companies, minimizing that duplication of effort and variation in results. So let's discuss the adoption challenges for these more reactive technologies. Cost, again, is the first one. Well, typically less than that AR or VR or digital human modeling, these technologies also come with a price, especially since the wearables and exoskeletons usually have to be provided to each employee in that target area. You also want to make sure you have worker buy-in. Most workers don't like the thought of Big Brother watching them, especially when it comes to using wearables and vision systems. So it's important to address that issue if you plan on implementing those technologies successfully. Scalability of deployment, for the most part, exoskeletons, computer vision, and wearable sensors are designed for a single person. And also with vision systems, many companies have strict video recording rules or need special permissions, which can hinder some of that adoption and scalability. However, a lot of the wearable sensors can be deployed across multiple people at once to collect data, and there are some efforts to use the vision system, computer vision systems to assist in to assess those multiple people at once. And then data accuracy, I mentioned, we're not quite sold on all of the accurate claims. Some of them are better than others. We do think there's a lot of potential, especially with the machine learning algorithms and as that AI improves with more data, but we do need to see some third-party validation testing done with that. And then the data security and privacy is always of interest to executives in HR, especially when there's videos of employees and risk metrics and they're being stored in a cloud server somewhere. However, the large companies are using this technology with cloud-based systems and they're becoming more secure. So this is working itself out a little bit. And the benefits to these technologies, if we can do that risk prioritization faster, if we can identify those risks and prioritize them and address them, that in turn will increase that worker safety. A lot of times we get stuck in that analysis paralysis, and that's why a lot of the computer vision systems, even though they might not be 100% accurate, they're good enough to help you identify some of those risky jobs and fix them, and spend your time with the solutions. And lastly, there's the opportunities that can lead to increases in productivity, especially with the use of cobots and some of the exoskeletons. So there are many more opportunities for applications of these technologies in health and safety and ergonomics in industry. The first one is going to be hiring. We can have a better understanding of the physical demands of a job and the functional capacities of the individuals. And in doing so, that can help with employee placement. Also, involving employees in that new technology shows that the company cares about them and cares about the exposures and wants to help optimize those jobs at an individual level. That can also lead to that increased employee engagement and retention, especially with the millennials. The millennials want to impact the vision of the company. They want to impact not just the bottom line, but they want to make a difference. And they really want to resonate with the visions and missions of a company and feel like they're leaving their mark. So involving those millennials in that technology and having them use it when they're training, it just engages them more and gets more of that buy-in. And with training, it can be very beneficial to use that technology. on the job, showing them the risks, reminding them of ways to avoid it, whether you're using an AR/VR setting or you're using short tutorials. But that training can have an impact in the future. Job prioritization, we could be using the data analytics and predictive analytics to determine priorities for addressing existing risk in the workforce by collecting and integrating risk factors on the job with other data that's already tracked and measured. Things like injuries, accidents, near misses, bottlenecks, quality issues, employee complaints. In most companies, this information is siloed in each of the respective departments. To our knowledge, no one is using that data collectively. So if the metrics for quality and productivity and safety and ergonomics were all tied together, if all of those data points could be analyzed in a cohesive manner, think of how that would affect businesses, highlighting jobs that are having issues in all those areas so they can be addressed. Because typically a job that's an ergonomic problem is also seeing problems in quality, in productivity, and in all of those other key measures. So if we can bring all that data together and address it, then we can avoid making those same mistakes in the future. From a job assessment standpoint, obviously the use of validated technology to conduct job assessments has the potential to help increase the speed and the accuracy of job assessments and won't require as much training or expertise to do so. The one thing missing from some of these computer vision systems right now is force data collection or the ability to predict forces being applied. And there are some researchers that have started to go down this road, specifically that we know of Purdue and the University of Wisconsin, Madison. They're using computer vision systems to estimate force exertions through facial recognition software. So there's growth down that path. Work is also being done to develop multifactorial risk models and cumulative exposure models. So having a better understanding of the interactions between that physical or biomechanical factor, the individual or personal factor, and then that social or psychosocial factor is key to better prevention in the long run. These types of technology developments will help us do just that and help us assess that cumulative exposure to the worker in the workplace throughout the course of their entire, not just day or week, but in the course of their entire life. So those are the tools that in the future, if we can bring all of that stuff together, we have components for each of those, but we need to bring them together in a more cohesive fashion. And when less time is spent on analysis, more can be directed towards optimizing the best solutions for controls. Predictive analysis could be used to generate solutions and return on investment models. And there's some movement on this front as well. And lastly, technology is all about using data to make informed decisions, which allows us to better evaluate our overall programs, cultures, and continuously improve it based on data with these emerging technologies. So with the fast growth in emerging technology fields, it's important to get involved in understanding and developing various technologies to advance our field. And there's a lot of potential out there in the future. If you're considering some of these new technologies within your ergonomics programs, a few thoughts come to mind. Consider which technology is going to address your low-hanging fruit and provide the biggest impact for you. And don't recreate that wheel if you don't have to. Take the time to do some research, see what others are doing out there, some of the companies that I've mentioned. Find out what's working and what isn't, and what process considerations might be needed. And then conduct a cost and benefit analysis. When you do, don't use just injury data. Look at the impact that technology might have on other key measures like quality and productivity, and you're likely to get more buy-in from your stakeholders. And then try it before you buy it. I really like to encourage folks, take the time, do that research, and then do a pilot study. Make sure that the technology is the right technology for your problem and that it's going to provide the solutions and the benefits you expect without any unintended consequences. Pilot studies also allow you to get that employee input and buy-in early on. So we want to try it, get it out there, make sure that it is going to help and do what you want it to do before you expand it. And then the cool factor. Just because it's cool doesn't mean you need it, or that it's the right solution for your problem. But it can still be cool. It can still be out there. It can still be something neat. It just might not be what you need. So you want to find that technology that's going to address your issues. And a great place to start and get some ideas, I encourage you, is the Applied Ergonomics Conference. We've been the sponsors for 20 years of the Ergonomics Cup, the Ergo Cup competition that's held there. This competition allows companies to showcase successful projects and programs, and it's a great opportunity to learn from and network with others. If you can't attend or you want to see what it's about, check out or Google the AEC or Applied Ergonomics Conference Ergo Cup, and you'll find several videos out there with compilations of past participants to show you some of the example projects that have been done. This is one example from this year for Tesla Super Tub. So their design engineers use that digital human modeling to design a single piece casting that replaced 70 parts and fastening elements. It replaced 300 welding and fastening robots and a number of stamping and welding processes. It improved their ergonomics conditions and avoided injury cost by over $380,000 per year and had labor savings of over $7 a vehicle. So they reduced their manufacturing costs by 40%, improved their rear crash performance and their noise and vibration and harshness. So all of these key measures are not just injuries. You know, they did this solution, they used their digital human modeling, and it was in part to affect ergonomics, but they looked at all of these other key measures to justify their change. And that's typically what you'll see happen is if you address an ergonomic issue, there should be some good benefits there, because when you design things correctly for the employee to be able to work and design that human system right to their capabilities, it should positively impact your productivity, your quality, and all your other key measures. So this actually won the Ergo Cup for engineering-driven workplace solution category. And another place to check out is the National Safety Council's resources. This is part of their MSD Solutions Lab, which was sponsored by Amazon, but there's a ton of great professionals on there. And we're all kind of working together, and NSC is coordinating and putting together some different infographics and resources out there. They've also provided some grants, and they recently announced their grant recipients. They've done some grants to industry and academia, and these grants center around the application or validation of different technologies. So Rutgers won a grant to implement an automated image capturing system designed to help employers better identify ergonomic risk factors and real-time solutions. Iowa State was awarded a grant to develop a predictive model and an AI-based ergonomics app for risk assessment and mitigation that will enable employers in high-risk industries to understand shoulder musculoskeletal disorder risk and different scenarios impacting their workers with and without an exoskeleton, so they can make more informed decisions. And then Virginia Tech was awarded a grant to implement inexpensive camera-based markerless sensors, along with machine learning models to assess worker physical exposure and MSD risks more efficiently, accurately, and comprehensively. And then Waterloo was the last university awarded a grant to generate evidence-based guidance on computer vision-based MSD risk technology in the workplace, so employers can better determine their optimal approach and timing for integrating computer vision-based MSD risk assessment tools in their programs. So you hear in there, you hear the exoskeletons, you hear the computer-based vision assessments, AI and predictive models. These are all those technologies. So the reason I list these is because all of these universities and several companies that were awarded grants to do pilot studies with computer vision and exoskeletons. All of these award winners will be reporting the results of their research in the coming year or so. So keep an eye out for that. These are all kind of at the forefront, and these are actually, these grants allow not only new developments, but also kind of validation of some of these technologies in industry. And wherever you might fall on the spectrum, just know that it takes time and purposeful effort and planning to get to that world-class level. You want to keep in mind that millennials, our new up-and-coming workforce, are more safety conscious. Remember, they're going to be 75% of the workforce in 2025, according to that Gallup poll. So we want to keep our workforce, and they're setting a higher bar than previous generations. They want to know that companies take their personal safety seriously. And if they don't see that you're at least kind of at that complying level, they want to look elsewhere for employment. So if you're using or planning to use technology in your program, involve them, involve your workforce, engage them, utilize their talents, and show them that you're willing to invest in their safety. And in summary, no matter what the industry, all those world-class companies are using technology to increase the effectiveness of the ergonomics programs, proactively when possible, that's ideal, or reactively when not. And there's no one magic solution, but if you take the time to plan and test and implement the right solution for your company and the work that you do, you can make an impact not only to your employees, but to that bottom line. So just a quick thank you and shout out to all of these resource centers. If you haven't, check out some of the research that they've sponsored and some of the webinars they have as additional resources too. And Alan, we can take any questions.
Thank you, Julia. Excellent presentation. That was a great roundup of some of this technology. I think if you would like, there are a lot of links here. If people are interested, you can request a copy of the talk in PDF format. I posted into the chat an email address. It's coehce@berkeley.edu. That's coehce@berkeley.edu. Again, it's in the chat. And if you would like a copy, please request through that address directly, and we'll get that to you, because there were definitely a lot of excellent resources in here. Yes, questions if you have any. Let's see. The first question that came in was, what are some of the leading indicators you're tracking? That was popped in early in the talk around the VR, AR, but I think it's perhaps just a more general question of some good examples of leading indicators.
Some of them are harder than others. And in the proactive side, so when you're in that design stage, one of the things you might look for is if you're doing assessments or you're looking at designs, and you have ergonomic criteria listed within your designs, you want to look at those. How many job tasks come up as green or come up as safe for ergonomics? What percentage of those jobs and functions are you allowing to go into the production stage that are not green or safe? You know, what's the percentage of, most places use red, yellow, green, high, moderate, low, whatever your criteria are. But what percentage of the job tasks that make it through that gate are not at that green? You know, do you start off at, like, I think Ford's number said, 90% of their issues were resolved before they moved on. So of the reaches and clearances. So that's one way to track a leading indicator. On the manufacturing side, a lot of people will do that with, you can do that with risk too, and how much risk is out there to begin with. But the training, that's more of a, how much of a workforce is trained, how much of them know what the word ergonomics means. Those are some of the things. Anything that is before an injury occurs, anything that you're doing proactively is going to be that leading indicator. Once that injury occurs, those injuries are those lagging. So the days away from work that we typically track in safety, the injuries, those are the things that we don't want to get there. So we want to find those metrics that come before that. And typically it's going to be your risk assessments. How much risk have you reduced out in the workplace, or how much have you not allowed to seep into the workplace from your design standpoint?
Great. We still have some time for some more questions. If you have any, please throw them in the Q&A box. If you have your hand raised, a couple of people do, for a question or comment, please just drop them into the Q&A box so that I can present them on your behalf. A participant attendee wanted to know if you could talk about any of this technology that you mentioned being used specifically in refining in the oil and gas industry. Do you know anything about that?
I don't know of any specifics. I haven't, I haven't worked with an oil and gas client in a long time, and I haven't seen any presentations recently, but I would guess, hazard a guess, that there are probably some ripe opportunities for some of those exoskeletons, if that is something that would work. It depends on the task, because some of those jobs, if some of those exoskeletons can't get dirty, some of them can. You know, it depends on the task that you're doing. So I would, if you're interested in that, contact some vendors and have them see what are the criteria that you need to meet, and see if some of their exoskeletons will work in that situation. And a lot of them are really good about giving demos and showing you things. And if you go to some of these conferences, WearCon is one, and the Applied Ergonomics Conference, where you see some of these exoskeletons and they'll let you try them, and you can have some of those discussions there too.
Right. Somebody asked if you know of any products that use the video-based assessment that doesn't involve the cloud, because they have IT issues, whether it be security or just trying to get through the IT walls.
Most of the ones that we've used have typically involved that cloud. There's a couple that we've not played with yet. So I don't want to throw out any that we haven't done, but I would, when you call them, that might be the first question you ask. Say, you know, do you have one that does not, where do you store your data? And is there any way that it can be stored within our systems? And their data integrity in the cloud, you know, a lot of these companies are used to dealing with those IT barriers, roadblocks, hurdles, whatever you might want to call them. So they might have some solutions. We didn't ask that because when we were testing them out, but I think if you would ask the vendors and just say, what's your solution to this? And most of them will probably work with you very, very easily.
Right. As a comment came in, it says, with the documented AI biases, we should be careful with products that use machine learning. And I'll use that comment to jump off into a bigger concept, which I think is there a way we could formalize this sort of do no harm philosophy into this new technology? As we explore this and we get ahead of ourselves, we get all this technology, we don't want to inadvertently introduce, solve one problem and introduce a new problem. Can you speak to that?
I mean, that's a huge ethical issue right now. I think even within academia, we've got professors who have said you can't use AI chat or you'll fail. And then we've got others that say all the students are going to be using it anyways. So how can we teach them how to use it properly and teach them where the systems are great and where they're not so great, and not, what data can they trust? Because that the implementation of that type of technology is skyrocketing. And I don't think the standards and rules around it are keeping up. That's why what Dr. Reed with the ASTM standard for exoskeletons, that model is excellent, because we've got a group of knowledgeable professionals who are basically keeping the interest of the worker in mind as these technologies go, and they're designing standards to keep those exoskeletons safe and make sure that they're not creating other issues for the worker. They're not moving, the load from the back to the shoulders or the shoulders to the back and just transferring that load. So they're coming around with these standards. I think we need that in some of these other technologies. I don't think they're all there. And that's why with the computer vision systems, that's why we're encouraging you to try it. Some of them are better than others. Some of them have strengths in some area and weaknesses in others. So make sure that whatever solution you want to try it out, get a job, do an assessment, try it out, and make sure that it's going to work for you. Some people think that the accuracy issue isn't that bad, and as long as it points them in the direction of where that risk is, they're good with that. And they just want to know, which jobs do I need to analyze? Others want to be more precise. So it depends what your ultimate goal is, because there's no one policing those right now.
Okay, we've got time for a couple more here. Question is, are we introducing new safety risks when we use cobots in the workplace? Can you give an example of cobot implementation that you're aware of?
Most of the cobots that I've worked with, we have actually a lab here, a manufacturing lab at the university, and they work with cobots all the time. And most of them have some of those safety features embedded in them. They're designed to be working with people, not the old robots that we used to have that had to be gated and everything around it. So Again, that's something that you want to pilot and try out. Ask the vendors, what are the precautions that are programmed into those pieces of equipment? But cobots in general are designed to work with people and, together, not to be boarded off. So are there risks? There's still probably risks in there, but they've been minimized to an extent. Again,
Sure.
depending on the vendor that you use. So
Got you. Somebody's asked if you know any good in-person ergonomic training.
I would always say yes, but we do offer ergonomics training. Also, a lot of the each OSHA region has training centers. The region 4, which was where North Carolina happens to be at another group within NC State, and they still offer a lot of safety training in person. And one component that they also offer is the OSHA 2255 Principles of Ergonomics class. And that is formatted a little differently across the regions, but they each have a qualified group to teach that class. And so that if you need have somebody who needs a quick basic introduction to ergonomics, that's one way to do it. It's usually a 3 to 5 day class, and I should say 18 hours to 30 hours. Depending on where you go, that you could usually take live.
Excellent. Well, since somebody asked, I will put in a plug for us. You can check out our COEH website, and you can see that we have a summer institute, which is really in-depth ergonomics training with some high-level operators. It just concluded for this year, but feel free to sign up for next year if you're in the Bay Area, from Northern California area, or not too far away. Come on over.
And I think each of the centers has one of those, right? I know the North Carolina one does too. So I think they all offer some type of.
Oh, good. I don't know the answer to that, but that's certainly some
Maybe
resources there that you can look up.
Yeah.
Somebody asked if you feel that PPE is the best category for exoskeletons. Is that where we should be putting them, considering them as PPE?
Most of the folks that I've worked with do. I personally do, just because it's really, you're not physically changing the job. You're not physically making an engineering change to the work. You're not reducing the risk. You're reducing kind of the exposure to the person by using that PPE. For me, when I consider engineering controls as I am changing the function, that job, and reducing that risk. I am changing the job tasks. Where the PPE is like, you put a glove on when you still have to handle something hot. So, but you put that heat resistant glove on. So to me, that's exoskeletons do fall in that PPE. Not all companies do view them as that, but a lot of them do. And that also, I think they do that because then they can tell the employee, in order to do this job, you're required to wear that PPE. And that makes it kind of more of a way to enforce, if you will, that this job requires this PPE when it's being done. So
thank you. Question: do you think this is more of your opinion, I suppose, is really do you think it's valid to use the mobile ergonomic apps for research work?
The computer vision systems?
They weren't specific, but I imagine something like the computer vision, maybe the posture recognition app. There was no context there beyond that question.
If it's a validated technology and it's been proven, I would not use it for research unless it's been proven. I know a lot of folks kind of do the dual. They'll do the cameras, the wearables, and the phones. And NC State also has on, I forget where the source is, on one of the free sources, and I'll include that in the PowerPoint, but they have a lot of their data that they collected with the biomechanics camera system. They downloaded that data so that you could compare it to some of the so the developers of the apps could compare it to what they're getting. So there's some free source information out there, but I would be hesitant to use it for research until you know that it's something that's been validated.
Yeah, that sounds like sound advice. Okay, last question. Do you know of any surgery environments where this is being used, where surgeons may have to adopt an awkward posture for a long period of time?
I personally don't. I know that I want to say that the Mayo Clinic was looking into some different types of, but don't quote me on that, but some different types of technologies. Some of them were more like the AR. I was talking to, I don't remember who it was, a doctor that was saying they were looking to using the AR VR so that a remote doctor who might be in another location could put on, the glasses and help the surgeon who might not be maybe an expert in that area complete the surgery. So, if the surgeon's going in and doing, I don't know, stomach surgery and has a heart issue and needs a heart specialist who can't get there, they could kind of remote in with that augmented or virtual reality and walk them through that process. So I think the medical industry is looking into that. I can't speak exactly to how or what.
All right. Well, hey, thank you, Julia. We did run out of time, and that was an excellent presentation. If I didn't get to your question, I apologize. Feel free to reach out to us for a copy of today's presentation in PDF format. And also, if you're logged in with your registration email, you'll get a link to an evaluation form that'll qualify you for an hour of continuing education contact hour. Again, that email is coehce@berkeley.edu if you have any questions. A big thank you to our presenter and to all of you who joined us today. We will catch you on the next one. Bye, Julia.
Alan.